And so the first one is conduction. So as I said earlier, so conduction, there are usually happen within solids. Conduction is the transfer of the energy without any movement of medium, because in solids, the particles cannot move. They can vibrate on their own position, but they cannot exactly move. So there are two ways that energy can be transferred in via conduction. Is through the vibration of particles and also through the movement of free electrons. Do you have an impression of these two things? So we have some descriptions. I have very wordy slides for this chapter because I think it may help you when you answer question. Like you can leave the answer from here and then make it part of your answer by simply rephrasing whatever I have here, rather than to totally come up with a new version of your own answer. So if it's by energy transfer via vibration of particles, so do you have any objection that solids are arranged in a close packed manner in a regular arrangement and they can only vibrate about their own position? No objection? Agree? Disagree? Okay, can agree with that or not first?
Agree.
Yeah, agree. So imagine we have particles, they are close together, they vibrate in their own position. So they have strong attractive forces here. So they cannot move. I mean, they cannot get far away from each other. So what happens if when heat is applied on this side, you see here, heat is applied on this side, then the particles on this layer will gain energy from the heat. So it will start to vibrate stronger. This will start to vibrate stronger. So when they start to vibrate stronger, they will cause the neighbor, this layer, to vibrate stronger as well. So this strong vibration is passed on from one layer to another because they are all very close together. So when the particles here vibrates as strongly as the first layer, right? That means the energy has from this part here get transferred over to this side already. Then energy is transferred through this vibration, and because they are very close. So in this case, right, you can say that solids are good conductor of heat. Compared to liquid, compared to gases. Liquids are further away from each other. So their particles are further away from each other. So if you want to heat them and transfer energy through this sort of vibration from one layer to another, it will take longer. And gases are not even in close proximity. So causing one particle to vibrate will most likely not be, you won't be able to transfer energy from one particle to another because the gap between the particles are too far away from each other. I mean, the gap is too big. So in that case, right, liquids and gases, you always call them poor conductors. So then the second case where you have motion of free electrons. So this one is only for metals. You have many types of solid, but this is restricted to metals. So metals, they are considered good conductors of heat because they have free electrons which are free to diffuse. That means, right, the electrons here, they are free to move anywhere. They move freely. So when you heat the substance here, this layer of atoms get the energy. The electrons here also near this section will also get the energy. So these electrons will then carry the heat energy from one end to another end. From the colder place, they will go to they will from the hotter place, right? They will go to the colder place. So the heat transfer will become faster because of all these free electrons. That's why later on, right, you will know that they will say that metals are the best conductor of heat. Then non-metallic material, solids, right, they are poor conductors, they are insulators. So then the reason for why liquids and gases are poor conductors. So this is written in word form, you can just lift it later on. So you say that molecules in liquids are further apart. So the transfer energy is slower in liquids than solid. So gas molecules are even further apart. So the transfer of energy is the slowest. So poor conductors are called insulators. Okay, so a takeaway from this section is solids conduct better than liquids. Liquid conducts better than gases. Then in solids, you have the non-metals and the metals. So the metals will conduct better than the non-metals. Then good conductor or insulators. So these are the few things you kind of need to know. Okay, can I continue? Hmm? So I have one question here. In this picture, you have ice, you have a glass tube filled with water. Then what happens is we will heat the top portion, which is here, and then the top part starts to boil. But we also see that the bottom part here, the ice, still remains as ice and it doesn't melt. So we are supposed to explain why the ice does not melt immediately, even though on top, the surface, right, is already boiling. Let's have you write something before we continue. The water molecules are further apart than solids, so it takes a longer time for the ice to melt. What does it mean?
It takes a longer time for the heat to travel down to the ice.
Yeah, then you should write it down, right? Right. If you write like that, right, you go for test, right? Then the teacher is not going to ask you, so why is it like that? Then after that, you stand next to her and then you explain to her. That is not possible. When the teacher sees this, he or she will just give the mark based on this. You have no second chance of asking you why. So you will have to write a rather complete answer. So add something to it right now. Let's see what will happen. The water molecule. There's There is more. Some more. So when you say that it takes a longer time to travel down the tube, you are implying that it is either a good conductor of heat or poor conductor of heat. So you will write it down in the question and indicate whether it is a poor conductor or a good conductor. So you will,
conductor.
water is a,
conductor. It's a poor conductor.
heat. So heat. So we don't need this. But I need this because therefore heat, it takes longer for the heat to travel down the test tube to the ice. Therefore, the ice does not melt immediately. If they ask you to explain in terms of molecules and particles, then you will add whatever that I cancel away just now. Okay? So say water is not a good conductor, heat cannot conduct heat well to melt from blah 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 blah. Part B. Part B. The diagram below shows the same thing again. At which part of the test tube does the water molecules have greater kinetic energy? So greater kinetic energy, what does it imply? Higher temperature.
The wire gauze.
The wire gauze. Why the wire gauze?
Because the wire gauze is a solid. And the
but you say which part of test tube do the water molecules, not the wire gauze?
steam.
On the surface here, because the temperature. Water at the upper.
Gas, because of the gas and the gas particles are further away from each other and are in constant motion.
So it's actually they ask about the water molecule. So the boiling water on the top part and the steam area, that is the area where the highest kinetic energy present, like what you say. Okay, next. What does the experiment show you show about the ability of water to conduct heat? Then you explain your answer. So you say that is a poor conductor of heat. So if water was a good conductor, the heat will be transferred to the ice quickly, and the ice will have melted before the water boiled. So we want to say that this is the property to show water is a poor conductor of heat. So this one is this part of the answer, the part one. Then explain your answer. This is the explanation. This one, the tiled floor means you have ceramic tiles or floor tiles. Feels cooler than a wooden floor normally. Then you say explain why is this so. You have to put one statement before this.
Wood is a poor conductor of heat.
They ask about the floor tile, and they ask about the tiled floor and compare to the wooden floor. So your answer should be written according to the tiled floor. So then you say the tiled floor is a better conductor of heat than the wooden floor.
There's no wood.
So the tiled floor will conduct heat away further, faster than the wooden floor. Therefore, it feels cooler, something like that. Heat is conducted from a heat faster than okay. So you must write because they say a tiled floor is cooler than this. So the main character of this question is the tiled floor. So you write according to the tiled floor. So you don't write the wooden floor is a poorer conductor of heat, but you write a tiled floor is a better conductor of heat. Okay, this one. Explain why food keeps cold longer if the walls are made of plastic rather than metal, or it's with a double skin. Plastic is a no, you don't write bad conductor, you write poor conductor. It reduces the heat transfer from the surroundings into the box through conduction. It reduces the heat transfer from the surrounding into the box through conduction. Thus, keeping a food colder. Do I have to mention the metal? What about the double skin? The air between the double skin is a poor conductor of heat. Okay, something similar.